Good day, ladies and gentlemen. This is the Endlessness Mechanic, and welcome to the ABG class. This is part two of ABG. Remember the last time it was a live class. We spoke of how you interpret ABGs in general, but we did not speak of the compensations. So part two of the ABGs today, we'll be speaking of the compensations, where we will be focusing on the uncompensated and the partially compensated. Part three of the ABGs, we will be talking about the fully compensated, because I don't want us to rush through it, because I want you to understand the content right. So remember, on the last class, technically, we spoke of how we interpret the ABGs, right? And in a nutshell, what I said was that you are given three main things, which is the pH, the carbon dioxide, and the bicarb. So what you're going to start by doing a quick recap. You first want to look at your pH. You want to know, is your pH acidotic and or alkalotic? In this case, our pH here is alkalotic. I'll write it like that. Right. And then we go to the next one, which is your carbon dioxide. We're given a carbon dioxide of 37. Remember that the normal carbon dioxide is between 35 to 45. Therefore, making the carbon dioxide what? It makes it normal. And then we go to the third one, which is your bicarb. Bicarb of 32. Remember that the normal values for bicarb is between 22 to 26. If it's greater than 26, it's alkalotic. Here we are given 32, which is what? Which is alkalotic. So what we are going to do, like I said, it's a quick recap, right? You look at the pH. If pH is alkalotic, you are going to match the pH with a gas that is alkalotic as well. In this case, you are going to match the pH with bicarb. Remember, when the problem is bicarb, it's a metabolic problem. When the problem is carbon dioxide, it's a respiratory problem, right? So here, since the pH and bicarb are matching together, it's a metabolic problem. And because the both of them are alkalotic, it means that this gas is a metabolic alkalosis, right? Now, looking at the compensations, we go back to the carbon dioxide. Remember that we go back to this carbon dioxide. Remember that under normal circumstances, when your patient is presenting with metabolic alkalosis, it means that the carbon dioxide, it's supposed to pull the opposite direction, meaning that it's supposed to be acidotic. In this case, carbon dioxide is not doing anything. Carbon dioxide is remaining normal. It's like the kidneys are going to the lungs and say, hey, lungs, help me. The lungs are saying, no, kidneys, I can't help you. I'm on leave. I'm on holiday. I'm in Mauritius. You understand? Meaning that the carbon dioxide is normal. If the carbon dioxide is normal, we are going to say that this gas is uncompensated. Remember, with your uncompensated, in a nutshell, what I'm trying to tell you is that a gas is uncompensated if, or an ABG is uncompensated if one gas is normal. In this case, in this example that I've given you, it is the carbon dioxide that is normal, hence making this ABG, which is called the metabolic alkalosis, uncompensated. I hope you understand. Let's go to the partial compensation. Right. With your partial compensation, we are given an example as well here. Let me change this color. I don't really like it. This one is better. We are given a pH of 7.34. 7.34. Remember, the normal pH is between 7.35 to 7.45. 7.35, if it's less than 7.35, we say that it's acidotic, acidosis, acid, isn't it? And then we go to our next one, which is carbon dioxide. Like I stated, the normal values for your carbon dioxide is between 35 to 45. If it's greater than 45, it's acidotic. Hence, the carbon dioxide, we are going to say that it's acid as well. We come to the bicarb. Normal value for bicarb, like we stated, is between 22 to 26. Greater than 26, it's alkalotic. It's alkalotic. And like we stated, that you are going to match the pH with a gas that looks like the pH. In this case, the pH is acidic, the carbon dioxide is acidic. Let's get them married. Now they get married. When they're married, remember we said that carbon dioxide is a respiratory problem. Respiratory, right? And the two of them are acidotic. Acidosis, right? Now we come to the compensations. We must focus on the bicarb that is remaining here. Focusing on the bicarb that is remaining here. Looking at the bicarb, remember, here we are acidotic, but then the bicarb is doing the opposite. It's trying to pull away. It's trying to pull away and be alkalotic, because the main aim here is that you want to neutralize the pH. So it's trying to do the opposite. So because now it's trying to do the opposite, because now it's not normal, we are going to say that this is what's happening to this marker. All right. This is respiratory acidosis, partially compensated, because partially compensated because you can see that this bicarb is trying to pull away, is trying to do the opposite of this acidosis. So guys, in summary, what I'm trying to tell you is that for us to say that a gas is uncompensated, one gas must be normal. For us to say that a gas is partially compensated, everything is abnormal. Everything must be abnormal. Remember, this is NCLEX, ne? So you need to understand this. Sometimes you just need to put 2 and 2 together very, very quickly. Quick recap. Uncompensated, one gas is normal. Partially compensated, everything is abnormal. If you want to know about how we do the normal interpretation, the normal ABG interpretations without doing the compensations, please go under live. There's that ABG live video. Please watch, enjoy, and please subscribe. I also offer private classes. There are the details. If you're interested, you can send me an email, you can send me a WhatsApp, and definitely I'll be willing to help. Happy studying, and please study smart, not hard. We study smart and not hard. This is the NCLEX Mechanic. Remember, the YouTube handle, it's NCLEXness Mechanic. Thank you very much for your time.